Welcome to Technology Advance YouTube channel. Today we are going to learn one of the most important HVAC concepts, heat. Heat is one of the most important concepts in HVAC. In simple terms, heat is a form of energy that moves from a warmer object or area to a cooler one. Everything around us contains heat energy, including the air, water, buildings, equipment, and even our bodies. In HVAC, heat naturally flows from high temperature to low temperature, until both areas reach the same temperature. A common misconception is that an air conditioner creates cold air. In reality, an air conditioner removes heat from inside a room and transfers it outside. For example, when warm indoor air passes over the cold evaporator coil, the refrigerant inside the coil absorbs heat from the air. The compressor then pumps that heat to the outdoor condenser, where it is released into the atmosphere. This process repeats continuously to maintain a comfortable indoor temperature. That's why HVAC systems are often called heat transfer systems. Their main job is to move heat where we want it, or remove it from where we don't. Understanding heat is the foundation of learning refrigeration cycles, airflow, superheat, subcooling, and HVAC troubleshooting. Now, let's learn about sensible heat. Sensible heat is the heat that causes a change in temperature and can be measured with a thermometer. In simple terms, whenever the temperature of a substance increases or decreases, sensible heat is being added or removed. For example, imagine a room with a temperature of 32 degrees Celsius. When the air conditioner starts running, the room temperature drops to 24 degrees Celsius. The heat removed from the air during this temperature change is called sensible heat. The important thing to remember is that sensible heat changes temperature, but it does not change the moisture content of the air. As HVAC technicians, we measure sensible heat using thermometers, temperature sensors, and digital gauges. In most air conditioning systems, a large portion of the cooling process involves removing sensible heat from indoor air to create a comfortable environment. The greater the temperature difference, the more sensible heat is transferred. Real-life example: before AC, room temperature equals 32 degrees Celsius. After AC, room temperature equals 24 degrees Celsius. Temperature drop equals 8 degrees Celsius. This 8 degrees Celsius reduction is the result of removing sensible heat. Now let's understand latent heat. Latent heat is often called hidden heat because it cannot be measured directly with a thermometer. Unlike sensible heat, latent heat does not change the temperature of the air. Instead, it changes the state of moisture. In HVAC systems, latent heat is associated with humidity. When warm, humid air passes over a cold evaporator coil, the water vapor in the air condenses into liquid water. During this process, the air loses moisture, and the heat removed from that moisture is called latent heat. This is why water droplets form on the evaporator coil and drain away through the condensate pipe. Removing latent heat is extremely important in humid climates. Even if the room temperature is comfortable, high humidity can make people feel sticky and uncomfortable. A properly operating air conditioner removes both heat and moisture to maintain comfort. As HVAC technicians, understanding latent heat helps us diagnose humidity problems, airflow issues, and cooling performance. Real-life example: before AC operation. Temperature equals 24 degrees Celsius. Humidity equals 70%. After AC operation, temperature equals 24 degrees Celsius. Humidity equals 50%. The temperature stayed the same, but moisture was removed from the air. This moisture removal is called latent heat removal. Now let's learn about total heat. Total heat is the combination of sensible heat and latent heat. In an HVAC system, cooling is not only about reducing temperature. It is also about removing moisture from the air. That's why HVAC technicians must consider both sensible heat and latent heat when evaluating system performance. The formula is simple. Total heat equals sensible heat plus latent heat. For example, when an air conditioner cools a room, part of its capacity is used to lower the air temperature. This is sensible heat removal. At the same time, another part of its capacity is used to remove moisture from the air. This is latent heat removal. When we add these two together, we get total heat. A room may feel uncomfortable if only sensible heat is removed and humidity remains high. Likewise, proper comfort is achieved when both temperature and humidity are controlled. Understanding total heat helps HVAC technicians perform load calculations, select the correct equipment, and diagnose cooling performance accurately. Real-life example. Before AC operation. Temperature equals 30 degrees Celsius. Humidity equals 70%. After AC operation, temperature equals 24 degrees Celsius. Humidity equals 50%. Temperature reduction equals sensible heat removal. Humidity reduction equals latent heat removal.
Total cooling effect, total heat equals sensible heat plus latent heat. This is the complete cooling work performed by the air conditioner.
Thank you for watching. If you found this video helpful, please don't forget to like, comment, and subscribe for more HVAC tips and tutorials. Your support helps us create more useful content for you. Thanks for being here. Compose right to technology advance.